Hello everyone. Today we'll solve Leetcode 155, which is mini stack. So here basically we have to design a stack which will perform these operations. Apart from standard operations, it has to return the getMin in O of 1 time complexity. So I'll explain the problem with an example over here. Okay. So see here, let's say these are the elements we are getting as a push method call. Then what would be the minimum value? For example, if we get push 3, then at that particular time min will be 3. Then if we get 5, then min again will be 3 because this is larger than the earlier min. Then if we got 2, then it will be updated as 2 and so on. So here if you see, we have to return the min element at every operations whatever happening, either push or pop. We have some algorithm which somehow return the minimum value at every operations. Okay, so let's think of some solution. So what we can do is, we have a standard stack. So as we need to return the min value along with push and pop operations, so what we can do, the simple solution would be, instead of storing one number, we can store a pair of number. Right? The first number will be the actual value and the second number will be the min. And whenever we are getting the better value, we keep on updating the min and storing the value as well. Let me just reiterate over this particular example what will happen. If you got push 3, then element that need to be pushed will be 3, and this time min value will be 3. Then next time when push 5 will come, and 5 will be pushed, but min value will be what? 3 only. Then again, let's say 2 comes, then min value will be 2 again. And let's say next 1 come, so min value will be 1, and again 1 comes, so min value will not update. Again if minus 1 comes, then min will update. So let's say at this particular point we got pop. So we'll remove this particular element, we'll return minus 1, and again the min value will change to 1. Again let's say pop again comes, this will return 1, and in min value will be 1 here. Again pop comes, 1 will be returned, and here again if you see someone asks for what is the min value, then you see the topmost element, what is the min? 2. Fine. So what we are doing is just the standard push pop operation and storing the one extra field along with the exact value. So let me show you solutions. So here what I did is, I created a node which has two values, one called value, other one is the min. So next I just created a node which is pointed at head. I'm using the linked list, and as we know that in stack, push and pop both operations happens at one end only, right? So I'm assuming that end is a head, so all the push or pop will happen from the head. So here in push, basically if node is null, we'll create new node and assign it as a head. If head is already there, then I'll create new node and accordingly arrange the links. For example, node next will be head and head will again be pointed to the new node. Similarly, if you need to pop, then just very simple, head equal to head dot text. Just increase the head. And for example, if you want to find getMin, it will always be the second field in the particular node. Fine. So if you can see, all the operations are O of 1. Fine. Let's think of some other solution. So here if you see, the only problem is we are storing one extra field. Let's see, somehow just by storing a single number can we do the same thing. what will happen here, if you store a single number, let's say 5 comes and 5 if you store, then if again we get a request, let's say pop or getMin, what I will return, I'll have only one value, right? Either it will be value, either it will be min. For example, let me take one more example. Push 3 comes, right? Then at this particular point, if pop comes, pop will be 3, and then if getmin comes, that will also be 3. But let's think about here again. 8 comes. Now if we got a request pop from the stack, then we have to return 8. But if you get the request of getmin, then that point of time we have to return 3, because so far 3 is the minimum element. So here at top, we have only single number, which is 8. We don't know that what is the min, right? So let's see, maybe we can take a variable called min, and every time when we get a new number, we keep on updating it. So what will happen here, let's do the same example again. Then let's say again 5 comes, there is no number over here, so let's update 5 as a min element. Let's say next number comes out to be 3, then what will happen, 3 is smaller, then you'll update min as a 3. Then see, the problem happens is, let's say at this particular point we get a request as a pop, then we'll return 3, right? And now at the same time we have to update this min as well, because now min has to be 5. But how we can do that? We don't have any other way, right? So now by this example, it will be clear that by storing the exact value what we are getting, we won't be able to satisfy both the conditions, finding the getmin and properly returning the values from the stack. So one solution would be, instead of storing the exact value in the stack, we may store the derived value. So if you store the derived value in such a way that we know that whether we are storing the derived value or the exact value, and so that we will be able to get the previous min as well somehow. Fine. So what we can think of is, let's say when we get a push request, what we can do, we'll store two kind of value, either the exact value, either the derived value. Let's say if whatever number we are getting, let's say we get push x, if the x is greater than min, then we are storing the exact value. But in other case, let's say equal to as well, in other case if x is smaller than min, then we are storing the derived value. What derived value you use? There are a lot of options we have. So for now, let's take simple 2x minus min. Later I will prove that what are other options we have and why I'm using this one. Fine. So if other case, we have to store this particular value. Fine. Then if pop comes, then what we need to do is, again we need to check the case key, pop the element. Let's say you pop the element and that comes out to be y. Then whether we need to return y or whether we need to return some derived value, and how we have to update the min. Fine, because once a smaller number, once min is going to be removed from the pop, then there will be next min, right? So min variable has to be updated. So what we can do is, once pop come, let's see what we need to return. We have two options, either the exact value, either the derived value. How we know that which value has been stored? By comparing this number, whatever you remove, with min. If this particular number is less than min, I'll prove this thing, that why it is less than or greater than, what would be the condition, I'll prove later. So for now, let's say if y is less than min, it means that this value which we have stored is derived. So what we need to return? We have to return the min only, because derived value is stored only if x is less than min, and that particular of time we also update min as well. So where x is there at min, so we directly return what? Min over here. And in other case, if this condition doesn't satisfy, then we directly return the whatever value we are popping out. So y will be returned in that case. Fine. So let me iterate with some particular example to make this thing clear. So let's say we have an stack and there is a variable called min. Let's say we got first push 5, then 5 will be added here because the first element, and min will become 5. Next day, let's say we got push 3. No, I'll not add. So what we will do is we'll compare with the min element. So 3 is smaller than min element. Then we have to add what? Derived value. What is the derived value? 2x minus min. 2 into 3 minus min, which is 5, which comes out to be 1. So we'll add 1 over here in this stack, and min will be updated as 3. Fine. Let me add one more element. So let's say we got 2. Okay. So 2 is less than 3. Then we have to store what? Derived value. What is the derived value? 2 into 2 minus 3, which is 1 again. So this value comes out to be 1 will be stored here, and next min will be 2. Let's say we got a request as pop. So if you get the pop request from here, then what will be returned, and what how we can update the min value over here. So here what will return, how we'll check whether this is the derived value or exact value, just comparing this number with the min value. If this one is smaller, so see here 1 is smaller than 2, yes, so this one is the derived value. What was the exact value? 2 only, because derived value is stored only if the value comes out to be smaller than min. So here what we will return? Min, which is 2. Now again we have to update min as well. So what would be the next min? So next min will be so I'll prove what would be the formula here. So it comes out to be 2 into this min element, currently min element. What? So in this case, what will be the next min? 2 into min element, which is 2, and y is 1. So 4 minus 1, which comes out to be 3. So now our min value will be updated as 3. Fine. As we see that so far first number comes out was 5, next number we pushed as 3, next number we pushed as 2. So this one has been popped. So out of these 2, what is the minimum? 3. So you can see it's right. So this way we can okay, let me just prove this push and pop algorithm, that why this is working, what condition we need to put, what formula I need to put, all of those things. Okay, let's start with this formula. If we consider this as a derived value, then what are the conditions we have in both the cases, push and pop, right? So if you took 2x minus min as the element to push as a derived value when the value you are getting, which is x, is smaller than min. In this case, if you are adding 2x minus min as a derived value into this stack, then what would be the pop thing? When you pop the element, then what will happen? So when you pop the element, how to know that whether this is derived value or whether this is exact value? So see, you push this element in case of this thing happen, right? So when you pop the element, how do you know that? You have two things to compare. So after adding this element, let's consider this as a y, okay, and you have a variable called min, which will be updated as what? X, because this one is smaller than min. Fine. So you have the variable min and you have this value y. So see, what is the relation between these two numbers? Basically, I wanted to say that what is the relation between 2x minus min and x. So here we need to define what is the relation over here. Then only you will be able to make sure that whether this is the derived value or the exact value. Okay, so So we know that this condition will happen here, right? So we have to somehow make it to be 2x minus min. So okay, let's do that. What we can do is x minus min will be less than 0. Fine, we have to make somehow 2x, so add x over both the places, so it will become 2x minus min is smaller than x. So see here, whenever the element you are popping is smaller than the min element, in that case we have stored the derived value. Fine. Next, in case of derived value, how we are updating this min? Fine. So let's see here what's happening. So what happened, 2x minus min is updated into the stack and the min value will be updated as x. Fine. So what we need to return, so we have to return when the pop request comes, we have to go back to the previous min, right? What was the previous min? This one only, right? Let's consider this as a previous min. This value you have to return, previous min. So how you find this value? So you know this y. So here what are the values you know? You know y because you pop the element and you know what is the topmost element. And you know this min, right? It means you know this x, right? If you know the x, if you know this y, then can't you find previous min? Of course. What would be the previous min? Or you can call it as min only. So min will be what? It will be 2x minus y. Where what is this x? This one is the current min. 2 into, we can call it as current min minus of y. What is this y? The element we have popped. So see, that's what I made here, 2 into current min minus y. Okay. So this way you can derive what element we need to pop, you know, what would be the condition and all those things. Okay, let's think about, do you have this only function 2x minus min as a derived value to push into the stack? Answer is no. We can use any such kind of function. What would happen is the conditions will change, right? When you pop the element, then the condition will not be like when your element popped has to be less than min, then you make sure that the derived value has been used. The condition might change. So let me just give you one hint. Instead of using 2x minus min, let's consider if you push the derived value as a x minus min, then what would be the condition, right? And how you going to update the min element? These two things will happen. So when you push this value, then x is less than min. So when you pop the element, what would be the condition? How would you make sure that if it is a derived value or if it is actual value? Fine. So see here, we know that x is less than min, right? Then what will happen? X minus min is less than 0. Fine. So this will be the condition. So once you pop the element, so once pop request come, pop the element and see if that element is negative, it means what? This is not the actual value, this is the derived value. What is the actual value? So here in x minus min, what is the actual value? X only, right? How to find this x? So see what we have done. If this condition happen, I mean x is less than min, then we are adding x minus min into the stack, and simultaneously we are also updating min as x. So what are the values we know? We know this min, it means that we know this x. Let's consider this as a y. We know this y as well. What we need to find out? This previous min. Can't we get it? Yes. You know the x, you know the y, you can find the min. What will be the min here? X minus y. So similarly we can play with any kind of derived function. Let me also give you one hint to use little different way rather than just a combination. So here what we can do is we might use similar to the approach one where we are storing two numbers, right? But both are in form of pair. Rather than we can store a single number but combination of twos. What I'm trying to say is, let's say you have two number x and y and you want to store these two in a single variable, and you have some mechanism so that you can get those values as well. So what you can do is just store something like x multiplied by n plus y. Now if you want to find x, what you will do is, let's consider this number is z. If you want to find x will be what? Z divided by n. If you want to find y, what would be z? This will be z modulo. Fine. So you can play with any kind of function, but here the condition would be n has to be greater than the range of values you have, x and y. So x and y will have some range, right? Let's say x, it will start from 10 power 4, minus 10 power 4 to 10 power 4 or something like that. Then you have to take n something larger value, right? 10 power 5 or something like that, so that you will get the exact value, not the, because in remainder you know that, right? If you divide or remainder will always return some number smaller than this. If you take n to be smaller than those numbers you have to return, you won't get the right number. Okay, I wanted to add one more point here. So if you see, if you have already given a stack implementation, let's say stack functions are already there given, which let's say work on int, and you have the push and pop function already defined, and you have to reuse these functions such that it will also support one extra method called getMin. You can't change the internal structure of a stack, then you can go with the approach 2. If you can change, then go with the approach 1. Fine. And one more thing I wanted to see here is stack is supporting only integer, and your range of values, for example whatever you want to push into the stack, that covers complete range of integer, like minus 2 power 31 to 2 power 31 minus 1, right? So if you cover all the elements in this particular range, then the formulas that we have derived, for example, either you can take 2x minus min, or you can take x minus min, or you can take whatever x into n plus min. So all those functions, what will happen is, if it covers complete range, then this will, all of them will be overflow, right? So in that case, what you need to do is, if already you have this function, then one option is you have to change this. If this is integer and covering all the range, then you have to use long here. That this particular element will take something like 4 byte or 8 byte or something like that. You want to save that particular step, that won't happen, because any derived function if you use, this will overflow if you already have the values within the complete range. Fine. So somehow we have to extend this, like 4 to, let's say it becomes now 8 byte if you convert integer to long. So if you see logically, both the approach 1 and approach 2, in approach 1 what we are doing, by default we are taking two values, right? Two integer values. Here what we have to do is, if we have integer, we have to convert it long. Then again, if you take the total space in both the approaches, it takes same. Fine. There is not much difference. And if you see the implementation, first one is very simple. I already showed you. So let me show you the implementation for approach 2 as well. So here what I did is, I used the stack already provided in the Java. So I just use long here, if you can see, and again I take one min variable, and in push methods, simply if stack is empty, I push and update the min values, and again if value is less than, then I put 2x minus min, otherwise the exact value, this is the derived value, this is the exact value. And same when it comes to pop, then we see whether it's derived value or the exact value. If it is derived value, we have to update the min. Fine. Similarly, if top is the function which return the peak element, topmost element of the stack. So if you see whether it's a derived value or exact value, depending on that, we'll return the which one we need to return, either the min, either the x. GetMin will return the min variable that we are keep on modifying during the push and pop operation. Fine. So all of these methods, if you can see, are taking off one time and one space. Thanks for watching. If you have any query or suggestion, please write into the comment section.